Welcome to day 3 of long distance learning. We're still studying waves. Today we want to talk about some example problems that involve the math and so on that goes along with these waves. Okay, so on the board you see that I've drawn a picture of a series of waves that are traveling a certain distance in a given amount of time. Okay, and before we can solve this problem, and you'll see some of these kinds of problems on a worksheet I'm going to post probably tomorrow, I need for you to understand some basic concepts here that go along with these waves. First of all, there is a wave speed. Another word for speed you should remember is velocity. We have two different formulas for waves. One of the formulas is this. You've got the velocity is equal to the distance divided by the time. So that's one equation that we could use for solving for wave speed. So if we have enough information, then we can solve for the speed or velocity of the wave using that equation. The second equation, I'm going to put a slash here, the second equation is that the velocity is equal to the wavelength times the frequency. Okay, so these are values that are not as well known, so we need to define these and establish what that really means. Okay, so first of all, the frequency is referred to as the number of wavelengths per second, or the number of wavelengths each second. The units for frequency are going to be hertz, like the car rental, and it has an abbreviation Hz. Okay? Now, the wavelength is the number of meters per wavelength, or it's just going to be in meters, but we know that the wavelength, the definition for wavelength, was the distance from the beginning of a wave to where it reoccurs. So let's look at the diagram right quick. If this is where the wave starts, then it's going to come through and it's going to reoccur right here. So now if I'm trying to count the number of waves that are in the diagram, I can say that there's one here, and then two here, and then three here, and then it ends with 4 wavelengths. So we can see in this diagram that one of the pieces of given information is that there are 4 wavelengths in the diagram. And we'll use that information in just a minute. Another valuable piece of information is that the period is the time for one wavelength. Okay, so how much time does it take for one wavelength? And that's based on the diagram again. And there's a simple equation that you will see on the physicsclassroom.com, but I want you to see it here first. And that is, and let's go ahead and mark this. The period has a unit called the capital T, and that is the time in seconds, but it's a special time. It's the time it takes for one. Okay, and then the equation says that capital T is equal to 1 over the frequency, and we also can say that the frequency is equal to 1 over the period. And so if you know one, you can solve for the other by just simply plugging into the equation and getting the other value. So that's kind of an important piece of information there also. Now, when I look at this problem over here, if I'm trying to solve for the speed, then I automatically have enough information because it's giving me the distance and it's giving me the time. So the speed is equal to the distance divided by the time, and the distance was 2 meters, and the time was 0.5 seconds, so the speed of the wave is going to be 4 meters per second. Okay? Now, if we know that value is 4 meters per second, then we know that 4 meters per second, which is the speed, is also equal to the wavelength times the frequency. So one of the things that we can look at is the wavelength is the distance for one wave from here to here. That's one wave. Well, if there are 4 of them in 2 meters, then each of these wavelengths is 0.5 meters long. Okay, so now we have 4 meters per second is equal to 0.5 meters, which is the wavelength, times the frequency. Well, in order to solve for the frequency, we are going to divide both sides by 0.5, and the frequency equals 8 hertz. And we remember right here, frequency, the units are hertz, or wavelengths per second. So, and that makes sense. If we could get 4 wavelengths in a half a second, then we should be able to get 8 wavelengths in a whole second, and frequency is the number of waves per second. So the frequency now is going to be 8. Now, if we needed to solve for the period, capital T is equal to 1 over the frequency. So that's the same thing as 1 over 8, and 1 over 8, let me grab the calculator right quick, I don't want to make a mistake here. 1 divided by 8 equals T equals 0.125 seconds. The time for one wavelength is 0.125 seconds. Now, another way that you can get that is that if there are 4 wavelengths that take place in 0.5 seconds, then you could take that time divided by 4, and that should also give you the same value. And try it on your calculator. You've got 0.5 seconds, let me clear that, 0.5 divided by 4 equals, and 0.5 divided by 4 equals 0.125 seconds right there. So I got 0.125 seconds solving it that way, and I also got 0.125 seconds solving it that way. So there's a number of different ways that you can get those values, but we will be wanting you to solve for the speed. We're going to want you to be able to solve for wavelength. We're going to be able to solve for frequency, and we're going to be able to solve for period. And go back over my calculations and double check, but that's relatively simple, and the examples are pretty close to being the same each time. Thanks for watching.